infectious diseases, research, medicine, health. Welcome to Outbreak News Interviews. And now, broadcasting from the Outbreak News Skylar Studios in beautiful West Central Florida, here is your host, microbiologist and editor of OutbreakNewsToday.com, Robert Harriman.
Well, hey everybody, this is Robert, and welcome to Outbreak News Interviews. Now, researchers at the Johns Hopkins Bloomberg School of Public Health found that a slow-growing variant form of the Lyme bacteria caused severe symptoms in a mouse model, which may account for persistent symptoms that are seen in up to 20% of Lyme patients that are not cured by the current Lyme antibiotic regimen. In addition, they found that these persister Lyme organisms were resistant to standard single-antibiotic Lyme therapy currently used, while a three-antibiotic cocktail eradicated the Lyme bacteria in the mouse model. Well, joining me to discuss these findings from a recent study in Discovery Medicine is Ying Zhang, MD, PhD. Dr. Zhang is a professor in the Department of Molecular Microbiology and Immunology at the Bloomberg School. Dr. Zhang, welcome back to the show, sir.
Well, thank you, Robert. It's a pleasure to be here.
Well, let's go ahead and start out since it is May and it's Lyme Awareness Month, can you give the audience a short summary on Lyme disease and some particular emphasis on the bacterial cause, Borrelia burgdorferi?
Yeah, of course. Lyme disease is caused by bacteria Borrelia burgdorferi. It's an unusual bacteria. It's a spirochete. It's unlike many other bacteria like Staph or E. coli. It has some unique properties. I'll come back to that. So the bacteria is introduced into human body through tick bites, and the tick can carry sometimes more than one pathogens and can cause co-infection problem as well. But here we're going to just focus on Lyme disease. So when the bacteria is introduced into the human body, initially the body response produces EM rash called erythema migrans, and then this localized disease form can spread through bloodstream into the disseminated form disease, where it can cause carditis as well as central nervous system symptoms. Then the disease can move on to develop the late stage disease like arthritis as well as central nervous system symptoms. But then that's just the textbook form of the symptoms. But then this persistent form of the disease called post-treatment Lyme disease syndrome. That is really very intriguing and not very well understood. And this is all really where the controversy lies. And our recent study may shed some light on this problem.
Well, let me piggyback on that. Can you try to define for the audience what is post-treatment Lyme disease syndrome and why is it controversial?
Yeah, so this is very unusual because it's really this is a problem that's really resolved by modern medicine. Because the current approach to understanding of a persistent infection relies on culture of the organism. For persistent infection like tuberculosis, when the disease relapses, then you can culture the organism from patient's sputum, which is all fine. But then in the case of Lyme disease, it's really very intriguing, very difficult to demonstrate that. So the current culture system is not perfect. So only occasionally one is able to culture the organism. But it's not really a predictable thing. So that's why it's easily denied, because based on the current standard, you can't really demonstrate the culture of the organism very easily. So that's why it's not really very easily accepted by the mainstream physicians, researchers, that this is a persistent infection. But on the other hand, I know patients really suffer a great deal, and they're not really cured. So the post-treatment Lyme disease syndrome is defined as the patient is diagnosed as Lyme disease with EM rash and then treated with a standard 2 to 4 week doxycycline treatment, but for 2 to 4 weeks. Then the patient is not cured, continue to suffer from symptoms like fatigue, musculoskeletal pain, neurologic symptoms that continue beyond 6 months. So, this is all the problem. So many mainstream physicians would say these patients after 2 to 4 week antibiotic treatment are cured. But they are not. They continue to suffer because there have been actually more recent studies that demonstrate, although we cannot quite culture the organism very easily, only occasionally, but then there are other indirect evidence that support that there is something still going on in the body's system, as shown by transcriptomic analysis by looking at the host response that seem to suggest continued inflammation. So this has been really a very, very difficult problem in terms of its care, and because such patients are not really taken care of by the current system. Their treatment is not covered. Then these patients continue to suffer. So there is no solution, essentially.
Let's get some clarification on another issue. What are persister Lyme bacteria? And is the pathology different from Lyme caused by the normal bacterial forms?
Yeah, so persister bacteria refer to the bacteria that are dormant, not growing, not killed by current antibiotics. So they actually, for any bacteria, they can form persister bacteria. For Borrelia, we and others have shown that Borrelia develop persister form. Indeed, in fact, very interesting, Borrelia, people are more used to the spirochete form of the bacteria, but that's not the most important form of the bacteria. So the Borrelia, in fact, is known to develop into variant forms. That is, they change the forms into round body forms, granular forms, microcolony forms. So these forms are usually not paid attention to. They're just considered to be some kind of variants, have no significance. But our study has shown that these variant forms are persister bacteria that are not killed by the current Lyme antibiotics. In addition, these variant forms can cause more severe disease in the mouse model, which we recently published. This was quite surprising because, we didn't quite expect these variant forms to be causing more severe disease in the mouse model. So this is really something that may provide new explanation for the PTLDS condition, because we showed in our study that these variant forms not only more tolerant or resistant to current Lyme antibiotics, they cause more severe disease in the mouse model. So we came up with this model inocular-dependent severity of disease, where it depends on the status of the Borrelia bacteria in the tick. So if it's a persister form or this microcolony or biofilm form being introduced into the human body, then it's likely that they do not respond well to the current single Lyme antibiotic like doxycycline or amoxicillin. But then they continue to cause problem, that's not really taken care of by the current single antibiotic. So this actually provides some explanation potentially for the PTLDS condition. But of course, there are other theories like antigenic debris due to dead bacteria that's really not cleared by the immune system that cause continued inflammation. There are other theories like the damage already done, you can't do anything about. There's also the theory it's just pain or aches of daily living. You can't really do much. But of course, there are more objective studies, as I mentioned before. Dr. Zhang from Johns Hopkins here at Lyme Disease Center published a range of studies that show that these PTLDS patients indeed have objective findings. That is, they have their cells produce this more inflammatory cytokines. In addition, the more recent brain imaging study, they also showed that the glial cells in the brain shown to be activated. There's more inflammation in the PTLDS patient. So these are all the signs that support. So this is a complex problem, to put it that way. Mm-hmm. This is not easy to demonstrate. But then we propose that. I know this is not easy to accept, but on the other, we have to take this on from different angles, from different approaches. One is one can try to improve the culture system. But there are some occasional studies, as I mentioned before, that you can culture the organism, but that's not a predictable phenomenon that in treated patients you can still isolate the organism. But there are ways that one can try, but that's for the future, to demonstrate that after treatment the organism is still there. But of course, the other way to show this would be to actually assume the infection is there. Then we try to use the persister drug regimen, that is using the more powerful persister drug combination like the one we reported in the paper, and show that if such treatments, persister drug regimen, can improve or cure such a PTLDS condition, then that would be indirect proof that such conditions exist. So now, I know it's a complicated problem.
Yeah.
I don't know that answers your question, but
yeah. And like I said in the intro, that you recently had a study published in Discovery Medicine. Dr. Zhang, can you give us a snapshot of how you performed this study?
Yeah, so basically we actually grow an old culture. So people previously used log phase culture where you get mainly the spirochetal form of the organism. So that's mainly the growing form. So in this case, we grow an old culture of a 10-day-old that contains different variant forms. So a log phase culture is like a 3-day to 5-day-old culture, but we used a 10-day-old stationary phase culture. So in old cultures, then Borrelia spirochete form would develop into variant forms. So in addition to spirochete form, it develops into round body forms, as well as microcolony forms. So the microcolony form is like a small aggregate, like a sphere, like a ball type of thing. It's aggregate of different cells, like a small biofilm. So we isolated these each individual variant forms, including the spirochete form, the round body form. It's actually the planktonic form, which contains both the round body form as well as the spirochete form, and also the microcolony form. Once we have the three different variant forms, we inject them into the mice. Okay, but before that, we show that they are in fact the variant forms are persisters. We show that they are tolerant to current Lyme antibiotics, and also we show that these variant forms we injected into mice can cause more severe symptoms like arthritis. Then using this model, we evaluated the persister drug regimen in comparison with the current single antibiotic treatment with doxycycline, ceftriaxone. So we showed that, in fact, there is different levels of persistence. So the mouse disease established by the spirochete, the growing spirochete form of the disease, is more easily treated, more easily cured with the current Lyme antibiotics like doxycycline, or in fact it's ceftriaxone is a cytal drug. It's more effective and can cure the Lyme disease caused by the spirochete form of the bacteria. However, for this microcolony, the persister form cause disease, then the current Lyme antibiotics, like even ceftriaxone. So ceftriaxone being the most powerful of the current known Lyme antibiotics, including doxycycline, amoxicillin, ceftriaxone, and then these three are the frontline agents. Then if the patient don't respond well, then it's given by IV ceftriaxone. So ceftriaxone is considered to be the most powerful indeed. This is a powerful antibiotic on its own. But then for the persistent form of the disease caused by the microcolony form, by the persistent form, it still cannot cure the persistent infection. That's shown by this culture of the ear punch. So this is just one way to detect the bacteria is still there. There are other ways like PCR. In fact, we have the unpublished data that in PCR, the culture data and PCR data are consistent. So, but in this model, then I mentioned that ceftriaxone cannot eradicate the persistent infection introduced by microcolony form, but can be eradicated by the triple drug antibiotic regimen consisting of daptomycin, doxycycline, and ceftriaxone.
Okay.
So this is important. This is actually the three-drug combination we showed earlier in vitro to be more effective as well. So it's gratifying to see the three-drug combination in vivo can also cure the persistent infection in this case.
Yeah. So that's a major finding there. So, Dr. Zhang, what's next on this research? What's the next step?
Well, our study right now is just a proof of the principle. I know this daptomycin is an IV antibiotic, is expensive, not easy to administer. So the goal is to develop an oral regimen consisting persister drugs that's able to be more easily administered or taken up by patients, as well as show excellent efficacy to be able to eradicate persistent infection in our mouse model. So right now we're doing a lot of drug combination evaluations of these different persister drug regimens. And I have good news to say that we have found other oral regimens that are equally effective. So we're in the process of doing the small studies as well as evaluating in this long-term persistence model. So I got email calls all the time from patients, and some complimentary, others more critical. I'm not saying it's not a good thing. It's actually pushed us to think. In fact, I know, as I mentioned, in fact, that there are two types of persistent Lyme disease. So one is this, which we published in the paper, which is what we call type 1 persistent disease, which is introduced by the tick bite at the very beginning. So even though the patient's diagnosed early, treated early, but still not cured. So these are called PDLDS patients. These are confirmed Lyme disease, so that they don't respond well to current Lyme antibiotic treatment. And there's a second type of persistent disease. That is, the patients have gotten infected by the tick bite, or oftentimes people do not know they are infected or they got the tick bite. And then sometime later, the patient found out that they had this Lyme disease, and they already get into the chronic form of the disease. So we call this as type 2 persistent disease, which is, maybe more difficult to cure, because depending on how persistent the disease is, how long the patient has had the disease. But this is an important group of patients that we are creating mouse model to mimic such patients and develop therapies as well. So we're right now in the process of doing a lot of mouse studies. As you can tell, it's really an exciting time to be able to develop more effective treatment for persistent Lyme disease.
Yeah, what a very complex situation. And again, the study was published in Discovery Medicine, and I'll link to that in the show notes when I publish the podcast. And I want to thank you once again, Dr. Ying Zhang, for sharing your research with us today.
Well, thank you very much, Robert.
All right, you take care.
All the best.
Bye.
Thanks.